Okay, so section 2.7, linear inequalities. In one variable. So again, let's recall the inequalities. Symbols. So less than or equal to, greater than, greater than or equal to, um, not equal, not greater than, not less than, which is actually the same as greater than or equal to, not less than or equal to, which is same as greater than, not greater than, same as less than or equal to, not greater than or equal to, same as less than. Okay, so again, let me give you the uh, additive property of inequality, the multiplicative property of inequality, which is analogous to the additive property of equality, additive property, multiplicative property of equality. So we'll be using those to solve linear inequalities. So the additive property of inequality. So suppose I have some sort of inequality, let's say greater than or equal to, then I can add the same quantity to both sides of my inequality, and my inequality remains invariant. Similarly, I can, let's say, subtract the same quantity from both sides of my inequality, and my inequality remains invariant. I also have the multiplicative property of inequality. And so, suppose I have some inequality, and suppose I have a positive constant. Then I can multiply both sides of my inequality by the same positive quantity, and my inequality remains invariant. Similarly, I can divide both sides of my inequality by the same positive constant, and my inequality remains invariant. However, if I multiply both sides of my inequality by a negative constant, then my inequality will switch. And if I divide both sides of my inequality by the same negative constant, then my inequality will switch. So it is preferable not to multiply or divide by negative constants. Let me again review interval notation. So let's first do the closed intervals. And so let's do the finite closed intervals. So let's say the closed interval from, and again, let me assume here that A is less than B. So let's have the closed interval from A to B is just a set of all x's between A and B, including both A and B. Okay, so let's see. Actually, maybe a little bit bigger. Oops. So includes both A and B and everything else in between. I also have the singleton. So maybe I'll. So this is just the singleton A. This is just a set of all. Oh, come on. Okay. Having some technical problems here. Okay, good. So let's just have the singleton A. So that just consists of just the value A. So this is just the single value A. Let's do the infinite closed intervals. And so the closed interval from A to infinity, this is just a set of all x's that are greater than or equal to A. So it includes A, and it includes everything greater than it. Okay. Next, the interval from negative infinity to A. So it's a set of all x's that are less than or equal to a. So it includes a, and includes everything less than or equal to that. Okay. Next, let's do the open intervals. So the open intervals. So let me do the finite open intervals. So the open interval from a to b, just a set of all x's, which are between a and b, but they do not include either a nor b. And so it's everything between a and b, but it does not include a, nor does it include b. Let's do the infinite open intervals. So a to infinity, the set of all x's, which are greater than a. So it includes everything greater than a, but it does not include the value a. Um, the interval from, let's see, I separated everything. Yes, good. The interval from negative infinity to a, so set of all x's which are less than a. So it includes everything that is smaller than a, but it does not include a. The half open, half closed intervals. And so suppose that we include a, but not include b. So a set of all x's between a and b. It, hmm, actually maybe let's move this up a little bit. Oops, let's include this. So include a, not include b, and include everything in between. Okay. Yes. So when A is so A is included when it says when there's an equal sign. Okay. So if there is a equal sign anywhere, then say there's an equal sign here, then we include the A. If there's no equal sign, we don't include it. So we don't include B here, don't include A, don't include A. There's no equal sign, so don't include A nor B. There is an equal sign, so include A. There is an equal sign, I include A. There is an equal sign, so include A. There are equal signs, so include A and B. Okay. And the other half open, the other half open, half closed interval, A, B. So the set of all x's such that x is between A and B. You include B, but you do not include A. So you include B, but not A. You include everything in between. Okay. Oh, and lastly, the Clopin intervals. And so everything, negative infinity to infinity. So this is just a set of all real numbers. So it's everything. So it's just everything here. And lastly, oops. And lastly, the empty set. So the empty set. So it's nothing. Okay. So let me do on page 88. Let's say problem number 2. And so in problems 1 through 24, graph the interval or find the inequality in algebraic form from its graph. Okay, so let's do that. So I have here x is greater than or equal to -2. And so let me graph this. So I have here, oops, so it's greater than or equal to -2. So I'll put a -2 there. And it is greater than or equal to, so I'll fill in the equal, and it is greater than. And so let me actually write this in interval notation. So it's the closed interval from -2 to infinity. Let me do problem number 10. -5 less than x less than or equal to 0. So this is the half open, half closed interval from -5 to 0. It does not include -5, but it does include 0. And it includes everything in between. And so it is the half open, half closed interval. Let me do problem number, uh, actually, let me do an example first. Let me do an example. For x less than 20 plus 2x. Suppose I wish to solve this inequality. So the first thing I can do is just treat it as if it were an equality. So let me subtract 2x from both sides of my inequality in order to isolate x on one side of my inequality. 4x minus 2x is 2x is less than 20. Notice that I've been careful here to to subtract the smaller value of x from both sides of my inequality so that I have a positive constant in front of x. So now I can use the multiplicative property of inequality to divide both sides of my inequality by the positive constant 2. Since it's a positive constant, I don't have to worry about the inequality switching. So I have that x is less than 10. And notice that I've written this in standard form. I've written it so that I can easily draw the graph of the solution from this. It's just the value of all my x's less than 10. It is the open interval from negative infinity to 10. Let me do problem number 87. Oops. In exercises, actually, maybe I'll do something before that. Hey, wait. Let me do, actually, let me do another one. Uh, Easier before that. Let me do problem number 52. In exercises 25 through 64, solve the inequality. So 9x minus 8 is less than negative 7. So let me use the additive property of inequality to isolate my x on one side of my inequality. So let me add 8 to both sides of my inequality. So I get 9x is less than 1. Let me use the multiplicative property of inequality to solve this inequality for x. So I'll divide both sides of my inequality by the positive constant 9. And so x is less than 1 over 9. This is the open interval from negative infinity to 1/9. I can draw this solution. And let's draw it a little higher. I can draw this inequality. So it's 1 over 9. Oops. And so it is everything less than 1 over 9. It does not include 1 over 9. Let me do problem number 76. In exercises 65 through 78, solve the inequality and graph the solution. 2x plus 9 minus 3x plus 7 greater than or equal to 5x minus 10. Okay, so let me get rid of all the parentheses. So I get 2x plus 9. I have a negative outside the parentheses, so I can change all the signs inside the parentheses. Negative 3x minus 7 greater than or equal to 5x minus 10. Let me combine like terms. 2x minus 3x is a negative x. 9 minus 7 is a positive 2. Let me add x to both sides of my inequality in order to isolate x on one side of my inequality. Be very careful that you choose so that the constant in front of x will be positive. And so I have 2x is greater than or equal to 5x plus x is 6x minus 10. Let me add 10 to both sides of my inequality. And so by the additive property of inequality, I have that 12 is greater than or equal to 6x. Now, let me divide both sides of my inequality by 6. Notice that 6 is a positive constant. Therefore, by the multiplicative property of inequality, I have that 2 is greater than or equal to x. But this is not in standard form yet. So I want to put this into standard form. In order for this to be in standard form, I want that my variable is on the left side. My variable is currently on the right side, so I want my variable to be on the left side. Notice that this arrow is pointing towards the x. So when I rewrite this in standard form, I have to have that my arrow is still pointing towards my x. So notice this arrow here is pointing to the x. And now I've written my answer in standard form, and that is the solution. It will not be considered my solution if I do not write this inequality in standard form. So notice that this is the closed interval from negative infinity to 2. And so let me graph this. And so it's everything that is less than 2. Less than or equal to 2. So it includes 2. And everything less than 2. And that is your answer. Let me do problem number 87. In exercises 79 through 94, solve the inequality. 6 x plus 1 greater than or equal to 5 plus x plus 3 minus 3x. Okay, so let me try to solve that. Let me multiply the 6 inside the parentheses. So by the distributive property, I have that 6x plus 6 is greater than or equal to 5 plus x plus 3 minus 3x. So 6x plus 6 is greater than or equal to 5 plus 3 is 8. X minus 3x is minus 2x. Let me add 2x to both sides of my inequality so that I can isolate x on one side of my inequality. So I have that 8x plus 6 is greater than or equal to 8. Now let me subtract 6 from both sides of my equation, from both sides of my inequality. So I have that 8x is greater than or equal to 2 by the additive property of inequality. Now let me try to solve this inequality for x. So let me use the multiplicative property of inequality. Notice that there's a positive constant of 8 in front of the x, so I can divide both sides of my inequality by the positive constant x. Since it's a positive constant, by the multiplicative property of inequality, I do not need to switch the inequality, so I have that x is greater than or equal to 1/4. This is already in standard form. It is the closed interval from 1/4 to infinity. It is the interval from 1/4. It includes 1/4, and it includes everything greater than 1/4. Okay. Ooh, that was it. Okay. Let me do, let's say, let's do that one. Question. Oh, can you write? The answer is no. Uh, so so the question is, could you write infinity 1/4? The answer is no. The reason you can't do that is because this guy here has to be less than this one. So this quantity must be less than that quantity, but this infinity is way over here. So notice that, actually, let me just sort of write this. So notice that this is 1/4, and this keeps going forever. So that's infinity. So this is the following interval. It includes all these numbers. So therefore, it is the closed interval from 1/4 to infinity. So you can just sort of look on the graph and see, oh, this keeps going to infinity. So it starts here, and then it goes here. So notice it goes in the same sort of, so here's negative infinity, here's 2. So it goes in the same order that you would see things on your graph. Yes, so if it's negative infinity, that is correct. So notice that the negative infinity is on the left, and the positive infinity is always on the right, and never vice versa. If it is, well, I'll just say never. Don't ever do that. Because if you do, then it means something completely different. Okay. Yes, it is good to know. Okay. Let me do, let's say, so we did, let's say problem number 94. 3 b minus 6. I don't like the b's and 6s. Let me do problem number 92, just because my b's and 6s look the same. So let's do problem 92 instead. 3/5, 15 minus 10a minus 2 less than or equal to 3/8. 8a minus 16 plus 5. Let me multiply 3/5, 3/8 inside the parentheses. And so, write each of these over 1. 15 divided by 5 is 3, times 3 gives you 9. 10 divided by 5 is 2, times 3 gives you 6a. Minus 2 is greater than or equal to 3/8 times 8a over 1. Well, the 8a divided by 8 is just a, times 3 is 3a. 16 divided by 8 is 2, times 3 is 6, plus 5. Combine like terms. 9 minus 2 is 7, minus 6a, greater than or equal to 3a. Negative 6 plus 1, plus 5, negative 1. Let me add 6a to both sides of my inequality. And so, by the additive property of inequality, I have that 7 is greater than or equal to 9a minus 1. Let me add 1 to both sides of my inequality. And so 8 is greater than or equal to 9a. Let me divide both sides of my inequality by the positive constant 9. And so I have that 8 over 9 is greater than or equal to a. So I can rewrite this in standard form. So a is, notice that the inequality is pointing to a, so less than or equal to 8 over 9. This is the closed interval from negative infinity to 8 over 9. It is the interval. It includes 8 over 9 and everything less than 8 over 9. Let me, okay. Let me do, let's say, problem number 100.
I have a question.
Sure.
The one you just did, why did you change the sign when you started doing it?
Oh, because I want this. So you're saying here, the very going from this step to this step.
Yeah.
Okay, because I want to write this in standard form. So standard form means that I want that the variable is on the left side of my inequality. So I want the variable on the left side. Notice that the variable in this case is on the right side. Remember, with inequalities, you must always have it in standard form, meaning you must always have the variable on the left side. For equalities, it doesn't matter if the variable is on the right or left side. But for inequalities, you must always have it on the left side. So you always want to write this in standard form. Okay?
Okay.
So that's why I had to, uh, no, that was already, that's why I had to like switch these around because I want these in standard form.
Okay.
Okay? Okay, so,
Can't you write it like how to how to write it like this that little thing like that
this,
line?
this.
How to do that? Yeah.
Oh, I divided both sides by inequality. I, right, I divided both. So this one, going from here to here.
Yeah. This one.
So notice that
Yeah.
these are all numbers less than or equal to 8 over 9. And so it includes everything less than 8 over 9 and includes 8 over 9. Therefore, it includes everything from negative infinity to 8 over 9 and it includes the 8 over 9, so that's why it's a closed interval. Okay?
Okay. Right.
Would there be a where we no? Uh, we always want to write our inequalities in standard form. You can keep your variable on the right side for equalities, but not for inequalities. So for inequalities, you always want to write them in standard form. Now, however, let me say if I have a three-part inequality. So I'll give you it's not quite what you asked, but it's somewhat similar. It's what's called a three-part inequality. So let me give you an example of that, a three-part inequality. So let's say that negative 1 is less than or equal to t minus 5 is less than 5. Okay? So this is called actually a three-part inequality. And so I have here that, you know, negative 1 is less than or equal to t minus 5, and t minus 5 is less than 5. So in this case, what we want is to actually isolate my variable in the middle. So in this case, what we want to do is add 5 to all three sides of my inequality in order to isolate my variable in the middle. And so I would get 5 minus 1 is 4 is less than or equal to. Uh, the 5's cancel. T is less than 5 plus 5 is 10. And so by the additive property of inequality, I now have isolated the variable t in the middle. And so this would be the half open, half closed interval. It would be all values of t. Now let's go a little below that. All values of t between 4 and 10. It would include the 4, but it would not include the 10. And it would include everything in between. Yeah, that right. Well, you said, is there a weird case? So I'm like, oh, let me think of a weird case. Let me do another example, which is similarly sort of weird. So another example. So let's say negative 2 less than negative 2 x plus 5 less than 10. So first off, let me multiply the negative 2 inside the parentheses. So by the distributive property, I have negative 2 is less than negative 2x minus 10 is less than 10. Oh, actually, let's have a equal sign there. Let me try to isolate the variable inside the middle. So let me add 10 to all sides of my inequality. So by the additive property of inequality, I have 8 is less than negative 2x is less than or equal to 20. Now let me divide all sides of my inequality by a negative 2, which unfortunately means that I'm divided by negative. And so now this is sort of the case I didn't want to look at because it's sort of the hard case. And so let's divide by a negative 2. And so if I do that, well, let's see. It says I'm going to have to switch around the inequality. So I have to switch around everything. So let's look at the 20. 20 divided by negative 2 is a negative 10. And I have my less than or equal to. So let's write the less than or equal to. The negative 2x divided by negative 2 is x. I have here a less than. So let's write the less than. 8 divided by negative 2 is a negative 4. And that is your answer. So notice that because you have to divide by negative, I had to do this sort of switching where instead of going from left to right, I had to go from right to left. And so um, you can tell what's going to be on the exam by looking by, well, we're going to have the go over the sample exam tomorrow. But if you look in your assessments and you actually look and it says exam for chapters 1, 2, and 3, uh, those problems in the assessment are actually the same problems I will be giving to you from the exam. So that's the exact same database. So the problems from that database are the problems that will be possibly on your exam. So if you have any questions about what sort of, if that could possibly ever come up, you would just look in those, uh, you know, on the assessments and see if that type of problem ever comes up. I don't think it does actually, but you can look. Okay. Let me do, let's say another problem. Let's say problem number 100, I guess. I was going to do that and never got to that. Okay, so in problems 95 through 101, use the inequality to express the statement in symbols. And so the cost, C, must be kept below $90. And so I have to have that the cost is below $90. And that is your answer. Let me do, let's say problem number, maybe 112. In exercises 102 through 118, set up and solve the inequality to solve the problem. Okay, so let me do that. Eric can afford to spend no more than $350 on a stereo system and some compact disc. If the stereo cost $180, and the disc are $9 each. Find the greatest number of disc he can buy. Okay, so let me do that. So let X be the number of compact disc. So the number of CDs that they buy. Well, the stereo costs $180, and each compact disc costs $9. So if you purchase X of them, then they will cost 9X for X of those. And, well, it says here that he has no more than $350. So no more than 350. Oh, so it's not more than 350. But let's look at the very, very beginning. What is not more than less than or equal to? So I already said here, not more than is less than or equal to. So let me not let me rewrite that. So 180 plus 9x is less than or equal to 350. So I'm going to rewrite that in the normal way as less than or equal to. So let me actually let's make that $360. Yeah, whatever. Let's make that $360. So let me subtract 180 from both sides of my inequality. So I have that 9x is less than or equal to 180. Now let me divide. So I can do that using the additive property of inequality. Now let me divide both sides of my inequality by the positive constant 9, since it's a positive constant. Then by the multiplicative property of inequality, I have x is less than or equal to 20. And so what's the greatest number of discs you can buy is, well, 20 discs. So that's the greatest number of CDs that he can buy. Any questions about that? Okay, good. Okay, let me do um, problem number 118. The amount of current used in operating a certain electrical appliance. Must be in the range of 7 amps to 9.5 amps. If 12 such appliances are to be used, what is the range of total current being used? Okay. Okay. So I have here that, oh, let's say appliance A. So I have that each of these appliances have a range of 7 amps to 9.5 amps. And so we're going to be using 12 of these. So let me multiply both sides of my equation, of my inequality, by 12. And so 84 is less than or equal to 12A is less than or equal to 114. And so the range is 84 amps to 114 amps. And that's the range currently being used of current. Okay, so that finishes off. That finishes off section 2.7, which finishes off chapter 2. Because there are 12 appliances. So they have 12 of these guys that are using this amount of current. Okay? And so that finishes off section 2.7, which finishes off chapter 2. And so I guess I'll have you guys do a group work, which is on section 2.7. And this will be due Sunday. Well, and so the password is solve linear inequalities. All one word. Also, recall that on Saturday, so on Saturday, we'll have exam number 1 review. At the same time, also, please, I guess, on Saturday, view the section 2.1 uh, video. I'll post that in a little while. And look over the PDF of that. Um, and there'll be a group work and do the group work for it. Okay. And that's going to be, um, again, due Sunday. So do this before class on Monday. Okay. So that we can start section 2.2 on Monday. Okay. Let's see. Any questions about anything? I guess we only have 10 minutes, so. Yes. So if you need any extensions on anything, please email me from within Educosoft to tell me to extend your homework. Uh, if you email me from within my LAVC email, I may not see it, so be sure that you do it from within the within the Educosoft. Okay. How do you print the sample exam? It's a PDF. So if you go to um, if you go to the so here let me oh I guess I can't do it. If you go to yeah so if you go to uh, documents and you just click on the actual PDF, it comes as a PDF, and you can just download or print any PDF as if you would print any PDF. Um, let's see if I can actually go to the website. I'm not sure if I can from here. I'll try. I may, unfortunately, crash the system. So, I'm going to try, but uh, we'll see what happens. Okay, let's see. Okay, let's see how lucky we are and see if it crashes or not. Student view. Okay, so I'll show you several different ways. Okay, so you could go to resources, documents, and you see here where it says sample one, where it says sample one exam, it says download. Well, you can just download it, and that will download it to your computer. Okay. Uh, or if you wanted to view it, you could view it, like I just did here, and from there you could print it. Just click on print. Okay. So that shows you how to. Is that clear? Okay. Next, let me go back, and I'll also show you from the tutorials. There's additional ways. If you go up here at the very, very, very top, here's exam one. Oops. Let's say, well, there you go. Let's say if you want to do this one, you could click here, and then from here you could also print it. Okay. So I have several different locations where you could look and print uh, exams. Okay. I guess that's about. Any other questions on Educosoft stuff before I close that. Okay, so I guess that's it for today. Okay, so I guess that's it for today, and I guess I'll see you guys tomorrow. Okay, registering for the site. What? One second. Let's just see what. Ah, so there'll be two group work. Yes, two group works. There will be two group works that you have to do by Sunday. What's the correct bubble to click on when registering for the online website? Oh, ah, please click on the one that says that you just want to purchase online access. Uh, that is the that will give you the ebook and that will give you access to the homework. Um, the other ones that would you would also be purchasing a hard copy of the book, and uh, you don't need to do that. Okay. Oh, and I should have sent everyone an email saying that one of the previous students is looking to sell a hard copy of the book. And so if you're interested, you can contact that person. Okay, let's see. Can do this. Okay, I think that's it. Okay, then. I guess I'll see you tomorrow then from the tutorial. Oh, from the tutorials. Oh, I just closed that. So you just go to the tutorials at the very, very top, and uh, there you can just, it's a PDF. So you can just click on it and just say save. So there, all you have to do is just say save. Okay? Oh, someone had my name. I didn't see that. That's funny. Okay. That's funny. That's okay. Um, no, I haven't activated it yet. I have not activated the group work yet. It'll be activated within the next, uh, half hour, 20 minutes. Okay. So yeah, that's okay. Uh, and so I guess I will delete everyone, remove everyone as a user, so that people can view this. Okay. Bye bye now. Okay.